Good morning, everybody. Welcome back to the e-Rum2020 stage. It's my pleasure today, deep pleasure, to chair the morning keynote, Tomas Kalibera. Please, Tomas, join us on stage. Tomas is a computer scientist. Hi, Tomas.
Hi, Roberta. Thank you
Here
for
we are.
inviting
Tomas is a
me.
computer scientist. He studies in computer science from the master degree to the PhD. And then he started a long movement around universities. You've been a lot around from Charles University in Prague. You went to Purdue and then you moved to Kent, Purdue again, Northeastern University in Boston, and then back to the Czech Technical University in Prague since 2016. The same year, he was elected an ordinary member of the R Foundation and joined the R core team. So Tomas, he's been working on different topics, starting from benchmarking during the PhD, on real-time garbage collectors, and then FastR, performance optimization, and he did a massive contribution to bug fixes for the R language interpreter. So Tomas, I'm really impressed because you did a lot of things in those years, and I'm fascinated by your topics, but most of all, I'm deeply grateful because actually I'm not a computer scientist. And so I know I cannot understand deeply in the technical details of what you do. But for sure, I can understand the value of your work as a user. I realized there exists garbage collector when I used a software system with a bad one. And for sure, it was not R. Never noticed a garbage collector in R. And I realized performances are really, really important when I had to rewrite my bad R code into a bad C++ code. As I didn't have enough computing resources at the time. I was younger, no cloud computing, just bad local resources. So, Tomas, I'm really, really proud to be here with you today. And I want to thank you for your work, because your work make my life better, for sure. And so, we are ready to hear your presentation now.
Okay, thank you. Thank you very much for having me.
Yeah, I just want to recall to the attendees while you are sharing your slides that questions will be on Slido. So don't be shy. Please contribute to the discussion, posing your question there. And Tomas, I'm warning you that I will be ringing a bell when you are 3 minutes left. 3 minutes left. Okay?
Fine. Thank you.
So Tomas, the stage is yours.
Thank you. So it's a pleasure to be here. Thank you for having me, and thanks to all the organizers for doing this great work. I am impressed how well it is working on a virtual conference. Of course, I would have preferred to be in Italy, but this is what we can get. So I will now switch on my slides and tell you something about how R is being developed. It's not just me. I will switch off my video so that you can see the slides. It's not just me, and I will tell you more about it. And I will tell you more about the changes that have happened to R recently. So for me, the core of R is the source code. It's the part of R that does the interpretation of the language, that has the bytecode compiler and bytecode interpreter, that has the core runtime, the garbage collector, the allocation engine, and that has the base packages, which is base package itself, but also stats, graphics, parallel tools, utils, and other. And also the core is documented. There is a lot of documentation that I believe all of you are using about the R functions. Then there is the R installation administration manual, writing R extensions. And these things are all for me the core of R. They are in the turbo that you can download. And without this core, none of the R packages could work. So who works on the R core? Of course, it's not just me. There has been a lot of contributors over the many years that R exists. They are all listed on the website. They have contributed code. Sometimes they have contributed other help. Sometimes we have reused code of other people who have not donated it specifically to R, but just to the open source world. But the core contributions, the main work is done by the so-called R core group that has currently 20 members, including those original authors of R. But some people have joined the group, some have left over the years. So recently, the activities of R core members are listed on this slide. These are just the latest year or latest 2 years for everyone. You can see there is a lot of active people doing different things on the core of R. Some of them are working also on things that are closely related, like CRAN, Bioconductor, and are very active in the R Foundation. You can see that many people are fixing bugs. This is taking a lot of time when working on R, and as you surely know, this is not just about fixing things that have been broken recently, but this is also about fixing things that have been broken from the beginning but never mattered, and now started to matter because something changed. And also oftentimes they are figuring out why things stopped working because the bugs are elsewhere in R packages or in the external software we are using. But we still, as the core team, have to debug these things to find out where the problem is. I will have an example in my presentation later. So where to meet the R core developers? Obviously on conferences on R and statistics. It's now harder when we have this Corona crisis, but hopefully it will happen soon. And then one can interact electronically with us. There is the R Devel mailing list, which is intended for technical questions about R, which are too technical for our help. Also discussing the development decisions on R and some discussing of bugs. Then there is the R Bugzilla, where people can submit bug reports indeed, and where people can also improve bug reports that have been submitted by others. And it's of course interactive, so the comments are also written by R core members, and all R core members see all comments that you write to Bugzilla. They receive it by email. And then there is one way channel of communication, which is the R blog, linked from our website, where we blog about things that happen in R, things we work on, things we change. A lot of the things I will be talking about today are mentioned on the blog. So what's new in R 4.0? It is the major release that has been released recently. Well, every R release has a news file which lists the changes. And in this one, and always we start with significant user visible changes. R 4.0 is a major release. So we thought that it was well, the least bad time to introduce some breaking changes. Things that we thought we had to change in the language and we knew that would break user code, well, maybe better in the major release, right, than other releases. But the rest is essentially invisible to users, and this is how it should be. Users should not be bugged every time there is a new release of R with changing their code. On the other hand, these other changes that are invisible are important for R to function and involve much more work than those visible, and I will speak about them in more detail. But let's first speak about the visible ones. I believe that many of you have heard of some of them. In 4.0, strings are no longer converted to factors by default when creating data frames. This is a big change to documented behavior. So it breaks a lot of packages that were relying on the previous behavior. It's really a bad thing to change the documented behavior. But we thought it was necessary. It was a hard decision. Kurt Hornig has been behind this, and he has written a blog post that you can read with all the details. I'm not a statistician, so I will leave the details to his blog post. Then another very breaking change was matrices and as arrays. So matrices as S3 objects in R are now also arrays, which means that methods written for arrays will dispatch on the matrix objects. This change has been done by Martin Meckler, and again, he wrote a blog post, so you can read his blog post about this. And this again broke a lot of packages. So maybe a surprising thing for you might be that a significant part of our work is debugging packages. And these breaking changes, these two of them have broken few hundred, so several hundred of cron packages. And part of this work is debugging these packages, finding out which ones are broken by these changes, helping the authors of these packages to fix them, sometimes also bugging them to fix them. This takes a lot of time and a lot of effort of the cron team, mostly. In the case of matrix as array, the breakage was mostly when packages were doing something they should not be doing, incorrectly using the class attribute. But still, yeah, we have to be helpful and not cause breakage of everything, right? In the first case, changing the documented behavior, that should be really, really extremely rare. And okay, another new significant thing is a new syntax. Introducing new syntax that doesn't harm anyone, of course, but brings new opportunities. And this is syntax for raw strings. So now we can enter in our programs string literals with backslashes, single and double quotes, without having to quote each of them. This is a syntax thing that is common in some other programming languages as well. And the syntax we adopted for R comes from C++. This is documented. You can check the details. An example is on the slide below, and this has been added by Luke Tierney. So let me now switch to the things that are invisible to users, except they are, in my opinion, much bigger changes. So the biggest change in 4.0, at least in terms how low level it is and how much work it was, is reference counting. This is something Luke Tierney worked on for several years. And it's a major change of the internals, how we track references to R objects. So R needs to have an estimate of how many references or names there may be for every R object. This information is needed when updating objects. If you have an element of a vector of million elements and you want to change it, if this vector is also linked from some other variable, you have to copy, right, as the R runtime, because R has this value semantics. But if you know that you are changing, let's say, the first element of X, it means you want to change the X, right? So if there is only one reference, you can do it in place, right? This is what the R runtime does automatically from R level. You don't have to worry. But you may notice the copying. So let's have a look at the example in R 3.6. This is the example below. If we have, I hope you can see the cursor well. If we have a vector of million elements, and we have a function to access the first element. Now we call the function to access the first element, And after the function returns, R believes, the old version of R, that the vector x that we pass to the function is now shared. This number 7 is bigger than 1. So R believes that this vector may be used by different variables. And hence, when we are changing an element of it, it has to copy it and change the copy. Now, the memory will not be wasted because the garbage collector will find out that the old copy, the original of the vector, is not needed, in fact, and it will wipe it and reclaim the memory. However, what is wasted is the time for the copying, in this case, of those million elements. In R4.0, with this reference counting change, this estimation of the number of references to object is improved. It can also go down, right? So after the same example, after we call the function that extracts the first element of the vector in this case, R knows that there is only one reference, at most one, to the object. And then when we want to change an element of the object, well, it does it in place. You can see the address is still the same, so we don't have to copy. So as you can see, there are already improvements, performance improvements, because of this change in R4.0. But mostly it's an investment for future improvements. There is hope that with reference counting, we will be able to optimize function calls, optimize the frame representation in function calls. And function calls are something that is very slow in R, unfortunately, and it's hard to improve. But with reference counting, some of that hopefully could be improved in future versions of R. Okay, so let me now switch to another thing that has been announced on the news file, another invisible thing that was also quite a lot of work, but think of weeks instead of years. And this is migration to PCRE2 library. PCRE is a library for parallel regular expressions that we have in R, in addition to the TRE regular expressions. And the old version of the library, PCRE1, does not support recent Unicode tables anymore. It's not updated anymore. PCRE2 supports recent Unicode tables, but has completely different API, or very different API in some parts completely. And so we decided we need to use PCRE2 in R. And to make the transition smoother, I decided to support both at the same time. So I have rewritten the layer in R that interfaces with the PCRE library so that it also supports PCRE2. This is a change that is invisible to users, well, except for some changes in the library itself. PCRE2 is slightly stricter than PCRE1. Brian Ripley has contributed also a lot of work in the configuration files and documentation to this change. As an illustration, every time we change something in R, well, we have to test it. We test it with packages. And so in this case, I have run all CRAN and bioconductor packages to test, as I do every time. And I run them with PCRE1 before the change and PCRE2 after the change. And then I compare the results. I look for packages that are newly broken after my change, because there are always some packages that are broken. Think of those 20,000 packages, right? And in this case, I was lucky. There were only several packages that were broken, and then I have to debug. It takes time, but luckily it was only several. And I found out that it was because they used some regular expressions that are no longer accepted. PCRE2 is stricter, so I communicated with the package authors, and they had to fix the package. My colleagues who were working on the breaking changes, they had much more work, hundreds of packages broken. Okay, so let me switch to okay. One more thing that changed recently in R. This is something I worked on with Luke Tierney, and it is a change or improvement in the sockets API in R. At the same time, it's improvement of the robustness of the R sockets layer, like fixing a lot of corner case bugs that did not affect us before, but now did, and improving performance of setting up computational cluster using parallel package, the cluster that uses the sockets, so psoc cluster. So a visible outcome is that setting up the cluster is much faster than before on systems that have many cores. You can see in the table below, the biggest speed up is on a Solaris server with 64 logical cores, which are quite slow cores, to be fair. And with R3.6, it took over 200 seconds. With R4.0, it takes 7 seconds, right? The speedups are big also on other of these servers that I have tested, but they are big because there is a lot of cores and a lot of clients that I run on these cores. So conceptually, the speedup is trivial. The old version of R was starting the client sequentially. The server will always create a socket, start a client, wait for the client to connect to the socket, then create a new socket, start the client, and so on and so on. After the improvement, the server will create a socket, and then it will start immediately all the clients, not waiting for them, and then it will be accepting connections from these clients repeatedly as they are available. To make this happen, as I said, we had to introduce a new API to R. We had to introduce server socket connections that represents these server sockets that are listening to connections and can be used to accept multiple incoming connections on the server. This is all documented because it's already in a released version of R. And while I was doing this, I ran into a number of problems because, well, I wanted, of course, this to work reliably. So I have inserted a lot of sleeps, like delays, into different places of the new algorithm for setting up the cluster to stress the server and the networking layer on the server and on the clients. And this way, I have found a large number of bugs in the sockets layer, and I have fixed them. I had to look at the TCP dump, for instance, so I had to read also some things about the TCP protocol that I either have forgotten or I never have known, and I had to watch the packets coming on the network. It was quite fun, actually, and hopefully in the end it is completely invisible to users. It would be only visible, well, by that it's faster, and if there are bugs, but I hope there will not be many. Details are on the blog posts again. Okay, and last example from the developments of last year or so is a big hunt for a bug that we did. It also first a warning. This is becoming very technical. There is no chance that in this very short time people can get all the technical details, but more of them are on the blog post, and I think it could be interesting as an illustration to possibly all our users. So this all started by Kurt Hornig from the CRAN team, finding that 20 packages from CRAN, imagine 16,020 of them, were failing with an unreleased version of GNU Fortran version 8, but they were passing the same version of packages, same version of R. They were passing with GFortran 7. Kurt and Brian mostly, but also others, we are testing R and packages with even unreleased versions of compilers to be able to see the problems early. And he has been doing this, and he found this problem. And I was asked to debug this issue. So I looked at one of these packages, and it had this C code that you can see in the slide, the inverse function. The inverse function is calling a Fortran routine DPO-SV, which is from LAPACK, this linear algebra codes. And this call in GFortran 8 has returned an error -1 coming from routine DPO-TRS. In the older version of Fortran, this was working fine. Okay, so I looked more at the code. I found the source code for DPO-TRS from where the error code is coming. And I found the line where this code is detected, right? The -1, it's the error code -1. Info equals -1 decides this is the error. And this error is reported by DPO-TRS when an argument to the function named applo is invalid, when it's neither U nor L. The argument is a one-character vector. It's a character. It's U or L, upper or lower. And yeah, it was regarded as invalid. However, I could see in the package code that the argument passed was U, so it was correct, which is strange. Well, I had a look at the function in the middle, DPO-SV, and I see that DPO-SV calls DPO-TRS with the argument applo. It's the argument it gets from the package, from the caller. It doesn't change it in any way. And after calling DPO-TRS, it exits right away, the DPO-SV function. Okay, so it doesn't make any sense. The package is passing U, and DPO-TRS says error because U is invalid. Yeah, this is not U. It's something else. So now I had to look at the, I ran the debugger, and I found the instruction using a watch point that corrupts the argument, that corrupts the applo argument. Typically, these problems happen due to memory corruption, due to bugs in native code of packages. That's common. People make mistakes, and they just corrupt random memory. So I have set a watch point, and using the debugger, I found the instruction that destroyed the value. Well, it was still strange, right? Because this was happening inside LAPACK, not inside package code. And really, the instruction that destroyed applo was inside DPO-SV, so inside LAPACK. And it was in the part of DPO-SV that calls into DPO-TRS just before it calls into DPO-RS. And it's really strange. Actually, it was several times last year that I had to look at the assembly to debug some problems in R. Unfortunately, this is relatively common. This was one of them. And so I had to read the assembly. I had to understand, write these comments. You can see these comments here. They are written manually by me, of course. Yeah, this is the assembly for 64-bit Intel machines. Anyway, it's very interesting. And it took me a long time to figure out, because I'm not a Fortran expert, what is going on. So you can see that there is a constant number 1 that is written to some place on the stack. And this place is also used by the applo value passed from the package. And so some part of this 1 in 64 bits is corrupting applo, and applo then becomes invalid, and then we get the error, right? So it made sense. But why the code generated by the Fortran compiler is corrupting the stack? Yeah. So it turned, when we look at the DPO-TRS, we see that there is no argument there that should be constant number 1. I checked, you can see my comments here. I was looking at which argument it should be, and then I figured out that it's a hidden argument, right? So this Fortran compiler on this platform, but it's common in Fortran compilers, expects these hidden length arguments that give the length of a character vector. In this case, the character vector is uplo. So there is one hidden argument at the end of the list, which is constant 1, says there is one character. And now this means that the compiler is passing this hidden argument 1 to DPO-TRS. But how come it's overwriting memory used by uplo? Well, the problem is that even DPoSV is taking the argument uplo, of course. And so even DPoSV should get this hidden argument. And the Fortran compiler was optimizing aggressively here, reusing the stacks log that it should have received from the caller, from the package. But it isn't, which is the bug. Yeah, I hear. So DPoSV was called from the package without this number 1 at the end. You can see the info. We have called it incorrectly, or, well, the package has called it incorrectly. Now, it turns out it's a big problem because we are not the only ones. Okay, R is doing itself such calls to LAPACK without these hidden 1 arguments. This number 1 is never used in LAPACK. The characters are always of length 1, so the number is never needed there. Almost all open source software I could see is calling without these number 1s. Some were doing it correctly, but yeah, I found out this way. Even the LAPACK, the reference implementation, it includes LAPACK E, which is a wrapper for LAPACK, is calling LAPACK incorrectly. So it's a widely used practice that has been broken by an optimization in GNU Fortran. On the other hand, GNU Fortran made this change legitimately by the Fortran standard. So all these calls were against the standard, right? Now, we have been, of course, talking a lot to the GNU Fortran developers, asking them to help. And, well, they did help in the end because LAPACK is very important code. And really, today, there is not much used for Fortran other than building LAPACK, right? A Fortran compiler that could not build LAPACK would be of no use. So a lot of things happened. But the first thing we did was that we added a compiler option to R when using gfortran to prevent optimizations that also include these ones, so that this problem doesn't trigger. We did it immediately, and so after several days of debugging, a lot of discussions, we just did this one line change in the configure script. And then we have fixed R itself to pass these hidden arguments. This has been done by Brian Ripley. And he has introduced macros that also should do this in R packages. All is documented in Dryintic R extensions. And finally, Fortran has been fixed. So the Fortran authors have changed at that time already released version of 7, 8, and 9. The 3 versions of Fortran, they have changed it so that they don't do this aggressive optimization by default. You can enable them, but by default, they are not done. Still, in the future, they may change their mind because they are allowed to do this by the standard. Okay, well, there is a lot of work on R, and we could use your help. And certainly, you can help even if you can't do this low-level assembly debugging. There is a lot of ways to help if people are willing and able to spend a lot of time and do some hard work, but only have basic R user skills. And this is helping with the bug reports. A lot of the bug reports are not perfect. They come with examples that are incomplete or are too big. They come with bug reports that are invalid because they are just doing, the people have misunderstood the documentation or something. Or bugs that have been already fixed. They are old and they have been already fixed, but they are not closed. So finding out about these can help RCore to spend more time on these hard low-level things. Of course, people who have more technical skills to debug some of these bugs, they could help a lot because it's common that I would spend days on a single bug. And if someone else does it, of course, I could spend those days on something else on R. I would like to thank especially those who have helped most with the bug reports recently. After this blog post that we have written with Luke Tierney, several people have been helping a lot, and most of them, these 4 that are listed on the bottom of the page. So thank you for your attention. Thank you for using R, and I will be happy to answer some questions if you have any.
Thank you, Thomas. Thank you very much for your very nice speech. I really appreciated that. Yes, now it's time for a round of Q&As. So I'm sharing the Slido page so that we can read also the questions posted by attendees and not only mine.
Mm-hmm.
Okay, I'm coming. I think maybe you see it smaller, too small, so I'm reading the questions for you, Thomas. So let's start from there. I have one question, but I leave it to the end. I love, the first question is, I love the names of different R versions. How you came up with them? Like the last one, See Things Now.
Yeah, I have to admit, I don't know. It's Peter Delgard who is the release master manager, and he's doing these things. And I hear something about some movies, and it's some very deep joke that I don't understand. Sorry. Yeah.
Yes, that's true. But it's true. I love them too.
Yeah.
So let's go to the second question. What's the most requested big change to our core you have resisted so far, and why?
Oh.
I have a couple of suggestions, but I let you answer.
I don't know. You have some suggestions? Well, there are some things that people ask, and some of them we don't think are so important, but would cause a lot of trouble. And some of them are things, and those we resist because we don't want to waste the time. And then there are some changes that we would really love to do, but it's not possible that quickly. And that's something we are not resisting, something we want. And one of these things is UTF-8 support on Windows. So for instance, we are really not resisting. It just needs more work, and I have written some blog about it too. Yeah.
So may I ask you to unshare your screen so that questions will be
Yeah, sure.
Please. Thank you very much, Thomas. So another question. Is the new R version compatible with tidyverse and Shiny packages, or should I wait some more time for bug fixes just to be sure?
It's a question for RStudio, right?
Yeah.
So it works the way that they are testing their packages with R, and they are updating them, and we are also testing, and when we see problems, we tell them. So they should be, but it's a question for RStudio. I don't know.
Yeah, this question, actually, if I can comment, I'm really curious to know your opinion on the topic relationship between our core and package developers. I mean, it seems to me kind of a delicate. It may be hard, it may be easy, but I would like to ask you, how do you live this relationship?
Yeah, well, there's a lot of interaction, right? When I started on R, I was debugging the bytecode compiler, and I had to interact with tens over the years, maybe 100 package authors, and most of them are people who are helpful and they want to improve their packages, maintain them well, and we are helping them all the time, right? We are debugging things for them, advising how to think, how to improve things, and so on. And then there are a few that may have trouble, right? But I don't think it makes the interaction hard, right? So some people, for instance, they implement their package in C or C++, and then it's a professor at the university, and then their students leave. And after a few years, I write them, oh, there is a protect error here. Could you fix it, please? And I tell them how, and they say, oh, well, yeah, we don't know C, we don't know C++, we would have to get someone who fixes, right? Even if I send them the patch, but it's still pleasant interaction. And And I think package authors should know that the cron team and sometimes other Arcore members are really debugging their packages all the time, right? Well, and then there are, of course, sometimes there are some arguments because some package authors would like to have even more control over what's happening in R. They want more API. I can tell you from my experience from other programming languages that R is extremely open. It is allowing packages to do way too much. That makes it so hard to maintain R and to improve R. So there is some tension that comes from these expectations, and there we stand on different places. And with my background, I can tell you that this is really not possible to open more of that.
Yeah, I think I understand that, because it's a supportive language, I think, R for users, very supportive. So let's go back to Slido for a couple of more questions. This one, is there a chance Arcore can open Bugzilla to non-insiders and or move to the code base to open and collaborative Git platforms?
Okay, so Bugzilla is open to everyone. The only thing is that you have to send an email to an address, say, please create me an account, and you will always get the account, unless you are a robot that is attacking us, right? So it's open completely. This email registration is there because we have been attacked by spammers, and that was a big problem. With Git, it's something else. We are discussing it, and we are not all in agreement in Arcore. But I would say that I know that it is not Git or or versus Subversion that would be limiting the number of patches that we could get, right? The problem is the quality of these patches, and I got to Arcore by sending patches, and certainly having to send them by email to Luke Tierney didn't limit me in any single way. On the other hand, this change may happen in the future when there is a majority in Arcore for that. Like patches can be sent through Bugzilla by email to RDevel list to concrete Arcore members. It's not a problem to send them.
Yeah. Thank you very much, Tomas. It has been very interesting. I'm sorry, we are running out of time, so I need to stop the Q&As, but we have a lot of very interesting questions on Slido. So I would like to suggest, if you have time, to reach the Open Lounge, which is a session. You can find it on the session menu.
Yeah, okay.
So that's all the attendees that unfortunately did not have their question answered can continue discussing to you. Okay. So please, thank you very much for your speech and also for your availability to join the Open Lounge session. Attendees will be grateful.
Yeah, I will be happy to. Thank you very much for having me here.
Thank you, Tomas. Thank you. So we have just one announcement to make before closing this stage session. Let me share my screen with you. Our in-kind sponsor, CRC, gave us 5 ebooks as a gift for attendees or people in the RAM. So we decided to assign those ebooks through a lottery. And as we've been supported so much from the staff members, and we decided to choose winners among staff members and travel grant winners as well. So come to the closing party this evening at 5 at the end of the last keynote speech. We are announcing the winners there. So please join us. That's it. I have nothing more to say, but please have a nice day here in e-Rum. Hope you enjoy as I'm doing. Bye-bye.